Hello everyone, welcome to A plus BI. This channel is all about complex numbers, and in this video we're going to be solving an interesting homemade system of equations with complex numbers. So we have z to the power ln w equals w and w to the power ln z equals 1. And we're going to be solving for z and w. Now I'll be presenting at least two methods. So let's go ahead and take a look. So starting with the first equation, z to the power ln w is equal to w. Do you think we can isolate z from here? Maybe write it in terms of w. If you raise both sides to the power 1 over ln w, you're going to get something like this. These two are going to cancel out, and from here we get z equals w to the power 1 over ln w. And is that something we can use inside the second equation? Let's go ahead and test it out. W to the power ln z, which is ln w to the power 1 over ln w. And then this is equal to 1. Now, we have an exponent. That's kind of interesting, ln of something, right? And if you can also evaluate the ln z first and then plug it in. That's another way to do it. It's probably better that way. But if you use the properties of logarithms, ln w to the power 1 over ln w is actually going to turn into 1 over ln w multiplied by ln w. And when the ln w's cancel out, you're going to end up with 1. What is that supposed to mean? Well, it just means that w to the power 1 equals 1, right? Which means w equals 1. So w is actually 1. And that kind of makes sense, doesn't it? Because if you really think about it, if the answer is 1, the base might as well be 1. But does w have to be 1? That's another question we need to raise, right? Maybe ln z is equal to 0. And again, we're working in the complex world, so things can get really complicated. So let's go ahead and approach this a little differently. Start with the second equation, w to the power ln z equals 1. And let's actually replace w with e to the power 2 pi ni. You got to remember, in the complex world, you can write 1 as an exponential. Thanks to Euler, we have this beautiful polar form. Now, if you are new to complex numbers, go ahead and check my lecture videos. I also have another channel that focuses on number theory, trigonometry, and algebra problems, and it's called Cyber Math. Okay? Now, after setting these two equal to each other, is there a way to write w to the power ln z as an exponential? Yes. So we can actually do this. Since whenever you have something like a to the power b, you can write it as, suppose a and b are complex numbers, we can write this as e to the power b ln a, right? So in this case, a happens to be w. So w to the power ln z equals e to the power b, and b happens to be ln z, so you can write it as ln z multiplied by ln a. But a happens to be what? The base in this case, so it's just the ln of w, right? And you want this to equal what? E to the power 2 pi ni. So from here we get the following. ln z times ln w is equal to 2 pi ni. Awesome. Is that something we can use in the second scenario? Let's take a look. We have w to the power ln z equals 1. Okay. Maybe we can just go ahead and, wait a minute. Didn't we just work with that? Yup. I mean the other one. Z to the ln w equals w. That's what I meant. Z to the ln w equals w. Okay. Now, notice that we do have an expression for ln w, right? So from here, there's a couple things we can do. We can isolate z again in terms of w and plug it in here. Or we can replace ln w with something. How is that going to work? I'm not sure. Maybe z equals w to the power 1 over ln w is going to work again. But it's going to be interesting because when you replace z with that, ln w to the power 1 over ln w, it's going to give you 1 again. And 1 times ln w, is that ln z? Yeah. ln of that times ln w is equal to 2 pi ni, right? So this is 1. From here, ln w is going to be 2 pi ni. And yes, we can do now e to the power both sides. W is going to be e to the power 2 pi ni, which is equal to 1 again. So no matter what you do, W is going to end up being 1, right? And it's kind of verified here on the system, isn't it? But let's go back to the original problem and try something else. Maybe we can go off of the exponent in the second equation. Now, when is this going to be 1? Maybe when the ln z is equal to 0. But if ln z is equal to 0, that just means z is equal to 1, right? I mean, what else can satisfy something like this? Okay, z is equal to 1, but not e to the power 2 pi ni, because if z is e to the power 2 pi ni, its natural log is going to be 2 pi ni, not 0. Of course, that's true when n equals 0, but we have to think about a general case here. So z equals 1 is implied if we go off of ln z equals 0. But if z is equal to 1, then from the first equation, we're going to get 1 to the power ln w equals w. Since this is also 1, w is going to be 1 from here. So it looks like they're both equal to 1, but wait a minute, how is that possible? Is that going to work? Let's test it out with the original problem. Z to the ln w equals w, and w to the ln z is equal to 1. Now, if you replace z and w both with 1, this is going to be 1 to the power 0. Oops. 1 to the power 0, which is 1 definitely. And if you do the same here, you get 1 to the power 0 again. So, yes, it will work. But this should tell you something. So let's go ahead and look at the second approach. The second approach is really, really cool, because it'll show you a really nice identity, okay, that you should definitely know. And this makes the problem a lot easier. So if you natural log both sides in both of these equations, let's see what you're going to get from there. This is going to be coming to the front. You're going to get ln w times ln z equals ln w, and ln z times ln w equals ln 1, which is 0. And then from here, you can kind of put those two things together, right? But here's what I'd like to tell you. Z to the power ln w is equal to w to the power ln z. This is true for real numbers, but is it also true for complex numbers? That's a good question. But if that's the case, then we're basically looking at the following. Remember, our system was z to the ln w equals w, w to the ln z equals 1. Since these two things are equal, which means w equals 1, which implies that z is also equal to 1. Are there any other solutions besides these? Z comma w equals 1, 1. Let me know in the comment section down below. And this brings us to the end of this video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.